Welcome to video 12.3. Today we're going to be doing a video on the introduction to probability. Our objectives for today are to find theoretical and experimental probabilities and to find geometric probabilities. In this section we're going to define the probability of an event as a number between 0 and 1 that indicates the likelihood that it will occur. So if an event will very much occur, we say that it has a probability of 1. If an event has no possibility of occurring at all, we say that it has a probability of 0. So an event that is equally likely to occur or not occur has a probability of 1/2. So if we're going to represent this on a line, we would say this would be our P1. So this means that it will definitely happen. P0 would mean the event will not happen at all, has no chance of happening. And then if P is 1/2, then the event has an equal amount of chances of happening and not happening. So we can represent a probability as a fraction, decimal, or a percent. So as a fraction, it's just 0. As a decimal, we can represent it as 0.00 or 0%. So a half, we can represent that as 0.5, or we can represent it as 50%. And if P was 1, that would either be 1 or 100%. Either way, depending on how the problem asks you, can represent it all three ways. In this section, we're going to be talking about two types of probability. We're going to be talking about theoretical probability and experimental probability. But let's look at theoretical probability first. So when all outcomes are equally likely to happen, the theoretical probability that an event A will occur is the number of outcomes in A over the total number of outcomes. So we're going to refer to the theoretical probability as just the probability of an event. So whenever I'm talking about theoretical probability or the probability of an event, note those definitions are interchangeable. So here in this diagram here, we want to know the total number of outcomes in event A. Well, here there's 4 possible outcomes, and in total there's 9. So we just divide 4 by 9, and that'll be the probability of an event happening. So let's talk about probability in terms of a 6-sided die. So we have a 6-sided die whose sides are numbered 1 through 6. Now we have these 3 scenarios we want to use to figure out what the probability of that event happening is. So the first we want to work on is A. So what's the probability of rolling a 4? Well, if it's a 6-sided die, we know that the number of ways to get a 4, there's really only one way to make that happen, that's rolling a 4. Now, the theoretical probability of an event, we have to divide this by the total number of outcomes. Now this is a 6-sided die, so there are 6 possible outcomes. So the probability of rolling a 4 is 1 out of 6. Okay? Part B, we want to roll an odd number now. So same idea. We want to think about the number of ways to get an odd number. Now think about the odd numbers from 1 through 6. It's 1, 3, and 5. And we're going to divide that by total outcomes, which is going to be 6. Now the numbers are 1, 3, and 5, so there's 3 different possibilities. If we simplify that, it's 1 over 2. And the final one is to roll a number less than 7. So the number of ways to get a number less than 7 is 6. There are 6 outcomes, so the probability is 1. So we've talked about permutations and combinations in the previous 2 sections. Now I want to talk about the probability involving permutations and combinations. So in this example, you're driving to school and you put on a playlist with 8 songs at random. So you go through all 8 songs without repeating any song. So the question is, what is the probability that the songs are played in the same order they're listed on the playlist? So for this, we're still talking about theoretical probability. So the first part I want to figure out is number of ways to play songs as listed. Because that's really what we're concerned about here. We want to figure out what's the probability that these songs are played in the same order that they're listed. And that's going to be over the total number of combinations. Now, since there's 8 songs, there's 8 factorial permutations of the 8 songs. But of these, only one is the order in which the songs are listed on the CD. We have these songs listed in a certain way, and that's only one specific way. So, the number of ways to play songs listed, there's only one way to do that. So we have our fraction 1 over 8 factorial, and I'm going to bring this up here just so we have some space. And when we do that, we have 1 over 40,320, which rounds out to about 0.00002. In part B of this problem, we have 4 favorite songs on our playlist. We want to figure out what the probability is that 2 of our favorite songs are played first in any order. Well, once again, this is theoretical probability, so we want to start off with words, and that'll help us figure out the numbers. So we want to figure out what the number of ways to play 2 of the 4 favorite songs. That's going to be over the total combination. So let's start off with the denominator first. I think it'll make it a little easier. So we want to figure out what's the total combination of picking 2 songs. Well, we know there's 8 songs, and what we have to do is choose 2 of them. So of the 8 songs, we want to figure out how many ways we can choose 2 of them. So this is our total combination. Now, ideally what we want is, since we have 4 favorite songs, we want to figure out how many different ways we can choose 2 of those 4. So, once again, let's recap. The total combination, we had 8 songs, and want to figure out how many different ways you can choose 2 of them. Now, on the top, we want to figure out the number of ways to play 2 of the favorite 4. So, of our 4 favorite songs, we had to figure out how many different ways we can choose 2. Then, when we do these numbers out, we end up with 3 over 14, or about 0.2. So, I think this first step is crucial for you to understand what's happening in the problem. And in this part, you have to remember the combinations. So I said at the beginning of the video there's going to be 2 types of probability. There's going to be theoretical probability and experimental probability. In experimental probability, we're going to have to look at more factual information, such as information we get from conducting a survey or looking at the history of a certain event. So let's look at the history about internet users. So in 1998, a survey asked internet users for their ages. The results are shown in the bar graph. Let's find the experimental probability that a randomly selected internet user is A, at most 20 years old, and B, at least 41 years old. So what we're thinking here is we want to just figure out how many of these users are under 21, and divide that by total users. So we know that under 21, there's 1,636 users. Now to find the total users, all we do is just add up these amounts. And when we do that, we end up with 12,443. When we simplify this, we end up with 0.13. So this is the probability that a randomly selected internet user is at most 21 years old. Now for part B, we're trying to figure out how many of the internet users are at least 41 years old. So it's a similar idea. We have to figure out what that number is over the total number of users. So we know the total number of users is 4, this number right here, and people that are at least 41. So at least 41 applies to here, here, and here. And we add those numbers up, we end up with 4,190. We simplify this, we end up with about 0.34. So we've talked about theoretical probability and experimental probability. We're going to talk about one more probability type called geometric probability. Now, in this type of probability, we can find the ratios of two lengths, areas, and volumes, and that can help us figure out the likelihood of an event happening. So here we have a dartboard where we are likely to hit any point inside the square board. So the question is, are you more likely to get 10 points or 0 points? Now to do this problem, we have to find two probabilities. The first one is, what's the probability of getting 10 points? Now to set up this fraction, we have to figure out the area of the small circle, the circle right here, divided by the area of the board. Now we know to find the area of a circle, we have to do the equation pi r squared. And to find the area of the board, which is a square, all we need to do is do the sides squared. Now we know from the diagram that the radius of the small circle is 3, so that becomes 3 squared, which is 9 pi. And to find the area of the board, we have to find the side length. Now all of the radius of this circle is 3, the radius of the second circle is 3, and the radius of the third circle is 3. All of these values right here are 3. So 3, 3, 3, that means this value here is 9. This has to be 9 as well. So the side length is 18. So area of a square is a side squared. So it's 18 squared. Now when we do this out, we end up with pi over 36, which is about 0.08. So that's the probability of getting 10 points, so hitting that little red circle. Now we think about the probability of getting 0 points, or hitting this blue area. So to do this, we have to find the area outside the large circle and divide that by the area of the board. Now to find the area outside the circle, we have to do is find the area of the square first and then subtract this big circle. That'll leave us with the blue part that we want to solve for. So we know the area of the big circle is already 18 squared, or 324. And then we need to subtract the area of that other circle. We know the area of that circle has to be 9 squared times pi. The reason I know it's 9 is because this is 3, this is 6, and that's 9. So this is just the numerator. So when we do the numerator out, we're going to end up with this 4 minus pi. Now we know the area of the actual board is 324. Now when we simplify all of this, we end up with 4 minus pi over 4, which simplifies down to to 0.215. So now that we have our two probabilities, we can clearly see that we have a much higher chance of getting 0 points. And that's where we're going to end our video for today. I hope this was helpful. Once again, take care and thank you.